has been declared as the World TB Day. Anybody amongst the participants, the delegates? I hope I'm audible to everyone. Okay, never mind. So here I am there to answer all your queries and your probably the questions about tuberculosis. To start with, yes, it is World TB Day, and we have been talking even past also. The present is with us, and future where the diagnostic of tuberculosis lies. This presentation is all about adhering to the various diagnostic modalities what we have in our system. To introduce, I think I don't have to mention it here. So how tuberculosis as a disease, it has come up, and what is a positive organism, that is the bacterium, Mycobacterium tuberculosis. It's an airborne infection and definitely very, very common for an immunocompromised patient to pick up this disease. Very affluent, and mainly 80% of the tuberculosis is mainly for the pulmonary, we call it as pulmonary tuberculosis, and 20 to roughly 25% is the extrapulmonary burden we have in our society. And of course, it can affect any part of your body, leading to the extrapulmonary symptom. To say that early diagnosis, so early treatment, early helpful for the people to come up with the treatment modalities, so have a control diagnostic and treatment part for the tuberculosis. As we all speak about, yes, India is one of the burdenous country, and 1/5 of the global incidence of tuberculosis is from my own country only, leading to India at the 17th position among the 22 high burden countries which are prevalent in over the world. In the global map, we stand at the 5th, we contribute to 1/5 of the global incidence of tuberculosis. So this year theme for World TB Day on 24th of March 2022, it is to invest more to end TB and save lives. I think the line itself says, as we all know, the burden is high. So everyone needs to supportive care, to invest into supportive care and help in funding of TB institutions, NGOs, so that we are more and more accountable in saving the lives people who are suffering from tuberculosis. What is the importance for today's day? I think if you're not aware of it, I have to mention it out here. The picture itself is saying it is Robert Koch with his favorite microscope, which was gifted to him by his wife, and which turned him to the level of the scientific research what he followed after that. So 24th of March 1882 was the day when the staining of the tubercle bacilli was discovered, and the definitive diagnosis was given by the tubercle bacilli was discovered in 1890 by Robert Koch, and later in 1905 he was awarded with Nobel Prize also. I have to mention you here, there are few of the famous personalities who were actually suffering. Not that it is a poor man's disease, even the people from the higher end and from the higher socioeconomic status also at one point of time suffered from this deadly disease. Talking about the Indian people, the famous mathematician Srinivasan Ramanujam, and Kamala Nehru, wife of Pandit Jawaharlal Nehru, she also suffered by this disease, and on the name of that only we have one TB Institute in Delhi. And Munshi Premchand, the famous Hindi Sahitya mein unka bahut zyada naam hai. So he also suffered from tuberculosis and died because of that. Few of the pictures. This is Ramanujan, Mrs. Kamala Nehru, and Carl Lieutenwald, one of the famous physician in US. He also suffered because of tuberculosis during his era. Talking about, when we talk about respiratory and the pulmonary or the extrapulmonary samples, so what defines and what are the basic samples what we need to take? For pulmonary, it can be a sputum. The first and the foremost, it should be a sputum sample, where the sputum is not expurgated, it cannot be spitted out. So you can go for a bronchoalveolar lavage, and in kids, you can take up the gastric lavage samples. Then in extrapulmonary, you name it, from head to toe, if it is tubercular meningitis, Koch's abdomen, TB lymphadenitis. So based on that, the exudative samples are collected. So the quantity of the sample matters. The inoculum should be high, and it will help in giving the exclusive growth of tuberculosis rather than the contaminants. The quality of the pulmonary or any kind of extrapulmonary sample, it should be very, very high. Then biopsies, of course, should be given a possibility. And think about the histopathology also when we are looking for tubercle. Not only the microbiologist, I think it should be a combination from the clinical features from the clinician, microbiologist playing a eminent role for diagnosing of TB, pathologists where we have a doubt, and the communication in these three people, clinician, pathologist, and the microbiologist should be eminent. So what does a poor quality and a good quality sputum looks like? So anything which is saliva or the nasal secretions should be discarded, and it is considered as unsatisfactory. It is not a relevant sample. Please ask for a sputum sample. If not, induced sputum, you can ask the patient to nebulize with a normal saline, and then they can experience their saliva, sputum sample. And a good quality sputum sample, which is thick and sticky, can be collected well in a universal container and should be transported to the laboratory ASAP, that is as soon as possible. So when we talk about the diagnostic things, when we talk about the diagnostics era, so we have the microscopic era, which is there. We have the culture era. ये भी एक time आया था, which is still common, and coming from a microbiologist, I think I will always support this. And then we have the molecular era. So past हमारे पास सिर्फ microscopy थी, present में हमारे पास culture भी है. Today's present, yes, we have the molecular things also with us. So briefly, I'll just elaborate all the procedures. So talking about the microscopic era, first and the foremost, we have the Zeden staining, the important one, the Zeal-Nelson staining, that is with the carbonyl question. And apart from that, the other mycobacteria, which can also be Mycobacterium lepra, or it can be any other mycobacterium other than tuberculosis, can also be diagnosed with this modified Zeden staining. So it will remain the greatest, it will play the greatest role and very, very helpful in our national tuberculosis elimination program. Pehle ise RNTCP kaha jata tha, that was revised National Tuberculosis Program, Control Program, and now it is called as NTEP. And for the dots, that is for the treatment modality. This 2 slide positive and 1 slide positive for sputum smear can be taken up and can be started for the TB treatment. So the threshold for the smear should be 10 to the power of 4, that is 10,000 acid-fast bacilli per ml of the sputum sample. It has a low sensitivity, and various times we are not able to differentiate between non-tubercular mycobacteria and tubercular mycobacteria only by simply Zeden staining. So that is why modified acid-fast stainings are available. Yes, it has the advantage that it has high specificity, very easily can be diagnosed, and very quickly we can diagnose within fraction of minutes, and very, very feasible at a very small, at a rural area, at a peripheral health centers also, we can have this. Just a microscopy, and we can identify whether the patient is labeled with tuberculosis or not. So therefore, it is the key diagnostic tool used for the case detection in NTEP, which was, as I said, previously called as RNTCP. Along with microscopy, what is newer with us? पहले हमारे पास सिर्फ Zeden staining था, Zeal-Nelson staining था. Nowadays, we have this fluorescent microscopy with LED illumination, where this auramine and rhodamine dyes are used. So the stains which were not picked up by Zeden staining could be defined by auramine rhodamine staining. There are multiple theories and multiple literatures which are available, which is very helpful for the diagnosis. So it is 99% sensitive, 82% specific, and 93% accurate results as per 2021 literature I have received. It is quite helpful in the newer areas where we can have this fluorescent microscopy, and we can, it is very helpful for the diagnosis of tuberculosis. So as I said, auramine and rhodamine dye. So yellow colored bacilli is seen on a fluorescent microscopy, whereas a red color bacilli, slender rod bacilli against a blue background. That is typically when we teach the MBBS students, that is how Zeal-Nelson staining tubercle bacilli looks like. If we talk about the grading, earlier we had this RNTCP grading. Nowadays it is called as National Tuberculosis Elimination Program, NTEP grading. And the other part, the right side, is showing the IUAT, the International Union Against Tuberculosis, that is for the fluorescent microscopy. So basically in the smaller setups or at the medical college levels, we are preferring the Zeden staining, but nowadays Having with this NTEP with loads of funds, I think we can go for this fluorescent microscopy. As I said, that it is more sensitive and it is more specific and it is 93% accurate. We can think of having fluorescent microscope with us. So wherein if we have to grade it, if there is no bacilli is seen in 100 fields, it is considered as negative. And same goes with the fluorescent microscopy for our RNTCP grading. 1 to 9 acid pass bacilli in 100 fields, it is considered as scanty. 10 to 99 bacilli per 100 fields, it is considered as 1 plus. 1 to 10 acid pass bacilli per immersion, oil immersion field seen for almost 20 to 50 field is considered as 2 plus. And more than 10 acid pass bacilli per field is, which is monitored for 20 fields, it is considered as 3 plus. So this is the basic RNTCP grading, I think we all know. And for the fluorescent microscopy, again, no bacilli in 100 fields, it is negative. 1 to 9 acid fast bacilli in 100 field, it can be AFB count, but let's go for a repeat sample. Then 10 to 99 bacilli again in 100 field is 1 plus. 1 to 10 acid fast bacilli per field in 50 fields can be considered 2 plus. And more than 10 acid fast bacilli per field in 20 fields is considered 3 plus for even for fluorescent microscopy. So this is just the basic difference. How do you say that? It is mainly the scanty one and the actual AFB count, which has to be made up by the two fluorescent microscopy slides. Briefly, if I can illustrate this graph. So with the progress of time and if the threshold of the smear, if the positivity and if the 10,000, 10 to the power of 4 bacilli, acid fast bacilli per ml of sputum is generally seen, the infectivity rate will keep on increasing if you're not treating it. So smear positive, high acid fast load, consider it if not treated well. So with time, the progression is going to be worsened and patient might be fatal for us. So what are the limitations for this fluorescent microscopy if we talk about? So at least 10 to the power of 4 bacilli per ml, it is required to consider it as positive, and less than that, we can give it 1 plus, 2 plus, 3 plus, and scanty also. It mainly does not differentiate about the mycobacterium in the first go, or else if you are suspecting it to be a non-tuberculous mycobacterium, think about going for another modalities. And quality of microscopy also underscores this procedure. So whether you have done the concentration techniques or not, the Petrov's method and the NALC method, I'm not getting into detail of it, but concentration techniques say ye slides बनाई हैं कि नहीं बनाई हैं, or it is just a random pick. So many a times when we get the CSF slide, if you're just putting up the slide, just putting up a drop of CSF and you're counting, looking for a TB bacilli, it is very, very difficult for you to diagnose. So I think the layering method is very important. So the quality of slide actually is directly proportional to how well you can identify the Mycobacterium tuberculosis in a particular slide. Okay, moving on. This was all about briefly about the microscopic era where we spoke about ZN staining, we spoke about the modified ZN staining, and then the fluorescent microscopy. Moving on to the culture era, this is very important. And as a microbiologist, I'll always say that yes, this is the gold standard. I am not biased, but eventually, probably after this this conversation, this webinar, probably you will be also helpful in some ways that how well we can diagnose with culture. So talking about, when we talk about, one second, excuse me. So when we talk about the mycobacterial culture, we have the solid media, we have the liquid media. In solid media, I think from MBBS we are reading, it is LJ media, that is the Lowenstein-Jensen media, which is the most important one for the diagnosis of TB, and ye purane time se chala aa raha hai. And we talk about the liquid media, the story started somewhere in 60s and 70s, and lately with 1980s we have Bactec, then we have the Bacti alerts, then we have the midget. One by one, I'll just deal with it. So talking about the solid media, the egg-based media, the Lowenstein-Jensen media. So what is the glitch with us? It takes generally 2 to 8 weeks for Mycobacterium TB bacilli to be isolated onto it, and we have the correct diagnosis. And how does typical colony characteristic on a LJ media looks like? It is a rough, tough, and buff colonies. Whereas when we talk about liquid media, that is Middlebrook 7H11, the time of detection can be less than preliminary report can be taken up in 15 days, 100% recovery from smear positive ones, and further, this liquid media can be used for drug sensitivity also. So where on LJ media we have this conditions how well we can put up the antibiotics, how well we can put up the anti-tubercular drugs, and then we can isolate from the LJ media. It is very cumbersome. Whereas on liquid media we can have this upper hand. So talking about the traditional culture medias, we had the egg-based, that is LJ media, then Dorset and Petragonese media, which is nowadays not being used. Then agar-based are Middlebrook 7H10 and 7H11. In Middlebrook 7H9, we have the liquid medias. Other liquid medias include the Dubos, Prosker, Sulas, and Soutons. Then we have the blood-based media, that is Tarshis, which are obsolete these days. Then it is a potato-based medium, Pawlowski's medium. So all these mediums, each can be made into a selective media by adding up into antibiotics. So when we talk about the liquid media, there are particular antibiotics which are being used that I'll deal later, that is called as OADC and Pentas. So on Lowinston-Jensen media, this is how the rough, tough, and the buff colonies looks like. There has to be a scoring, just like RNTCP's grading for the smears, we have the grading for culture medias also. I don't know, many of the books, they don't define it, but yes, there is a WHO scoring for culture medias also. So on a slant of LJ media, if you see no growth, it's considered as 0. You can count on the colonies on a single digit. It is report the number of colonies, but think of putting it on positivity. 10 to 100 colonies are there, it is +1. More than 100 colonies, that is just with a glitch, probably you can identify 2+. And innumerable colonies, that is the whole media is flooded with the rough, tough, and buff colonies on a green color LJ media, can be think of 3+. WHO scoring for the LJ culture media scoring. So what cannot be taken? First of all, I'll talk about the liquid culture media. Liquid, it is in a tube. So if at all this granular suspension can be seen, I think I can take the cursor there. So make a Zn staining out of that. Serpentine cords of varying length of district or linear clumping can be seen. Think about that. Yes, it can be a Mycobacterium tuberculosis positive. What is not considered as to be pulmonary Mycobacterium tuberculosis on a liquid media, if at all you have a froth deposition, homogeneous turbidity, froth deposition, think about it can be any of the spores or any of non-acid fast bacteria. Other contaminants apart from Mycobacterium tuberculosis can be Mycobacterium other than tuberculosis, MOTT, or the non-tubercular mycobacteria, or many a times it can be some kind of fungus which is not acid fast. Moving on to the liquid culture medias, we have the automated systems, BACTEC 460, BACTEC MGIT is Mycobacterium Growth Indicator Tube 960, SeptiCheck, and BacteriAlert 3D. First one is BACTEC TB 460. So when there is viable mycobacteria which are present in the culture, this radio-labeled palmitic acid is metabolized and the radioactive carbon dioxide is released into gaseous space. So that is the main funda of BACTEC 460. And the measure of the quantity, this instrument, how it measures quantitatively, it ranges from 0 to 999. That is the growth proportional area with growth indication we look for. So GI of more than 10 is considered as positive for Mycobacterium tuberculosis. Moving on to BacteriAlert or 3D. I think काफी सारे areas में, I think many medical colleges nowadays might be having this. This is one of the prerequisites for NMC nowadays. So again, it has a Middlebrook 7H9, which is a liquid medium, just like 460, BACTEC 460. So it has OADC. You might be wondering what is this? This is nothing but oleic acid albumin dextrose catalase. It is one of the medium which is already along with Middlebrook 7H9. It is there, and line of antibiotics which is called as Panta, comprising of polymyxin B, amphotericin B, nalidixic acid, trimethoprim, and azlocillin. So the funda for this bacteria is again viable TB bacilli, carbon dioxide is produced, which changes its color from green to yellow, and the sensor picks it up. The other modality, the automated modality, is BACTEC 960 MGIT. MGIT is nothing but Mycobacterium growth indicator tube. So the system, what here it is the system is also called as MGIT, and the tube which is inserted into the system is also considered as MGIT, that is Mycobacterium growth indicator tube. This also has 7H9 medium with the supplements of OADC and penta antibiotic mixture. So what happens? All the oxygen is consumed and the quenching effect, the lower down ho jata hai, so the fluorescent, it picks up and exposed to the UV light. So that's how the beep comes in. And we look for that, yes, this particular tube is probably positive for Mycobacterium tuberculosis. Then the last modality we have in automation is SeptiCheck. That is a biphasic culture approach. And again, it has got Middlebrook 7H9 medium. And before I switch on, one side, there are, apart from the liquid medium, above of that, we have two solid medias over that. One part of that is considering of Middlebrook 7H11, and the other half is considering of chocolate agar and 7H1 with NAP selective Middlebrook 7H11. This is how it looks like. So we have the liquid medium at the down, and we have a chocolate agar and 7H11 medium at the upper section. So on that, we look for the growth, and that's how we pick up that, yes, it is probably positive for Mycobacterium tuberculosis. So the whole picture, how it looks like in a cultural, when we are putting up the Mycobacterium tuberculosis culture. So we are decontamination, where we are doing it with NALC method or the Petrov's method. The culture method is adopted. So either you're putting up on a conventional method, or you're putting up, this side is Bacti alert and the midget Mycobacterium growth, or this is the conventional method, that is the LG medium. So as low as possible, from 2 to 8 weeks, we can have the identification, whereas in this automated systems, in preliminary report can be taken up by 15 days, or by 45 days, we can have the final report in our hands. Along with that, if at all you have to go for the drug sensitivity, which is very, very tedious for the LJ media, we go it for the automated system, that is in Mycobacterium growth indicator system only, we can have the drug sensitivity also. So that is followed by the line probe assay, which is coming further. Okay, so what are the limitations when we talk about the TB diagnosis, cultural TB diagnosis? Yes, it is time consuming. You require a well-trained personnel for this, who can identify that, yes, whether it is definitely a TB bacilli or it is just a contamination. And equipment has to be there. You need to have a microscope. You need to have this organized system, the automated systems if we talk about. So it is tedious in a nutshell if at all we talk about. Moving on to the molecular era. So it is a world in itself. You have n number of things here. You have n number of modalities here. It's basically a cocktail which you pick up. So molecular methods comprises of the basic one, the polymerase chain reaction, how it started, the conventional for PCR, gel electrophoresis, ligase chain reaction, cartridge-based nucleic acid amplification, nowadays a boon for the diagnosis of TB, for MDR TB. The other word to it is GeneXpert. Then we have the fast plug TB, restriction fragment length polymerism, and DNA probes, NASBA, and last but not the least, we have the sequencings. So what are the basic funda about this molecular TB, molecular methods for diagnosis of TB? Definitely shorter turnaround time, easily accessible, and you can have diagnosis within no time. Biohazard, so obviously there is less of exposure, so the less biohazard. Feasibility of automation, and early diagnosis of the patient, and helping in the treatment part. What are the different targets of amplification for different modalities? One by one, I'll just pick up. So PCR, I think we don't have to go into detail. What are the 4 steps of PCR? This is how the conventional light cycler used to look like. And nowadays with COVID testing, I think everybody knows about real-time PCR. Okay. Moving on to the ligase chain reaction. Apart from the 3 steps, we have 2 other entities. The rather than 2 oligonucleotides, we are using the 4-1. So it is much more specific than PCR, but just because it is expensive, it gives a thought whether, yes, we can go for it or not. What are the different genes which are being targeted for the diagnosis of MTB. If you're looking for isoniazid drug resistance, it is CATG, INH, and APHC. And rifampicin, RPOB gene, I think everybody knows by now. But pyrazinamide, PNCA, streptomycin, which is a second line of drug, RPSL and RRSS. Then ethambutol and quinolones. For fluoroquinolones, GYRA genes and A1, A3 genes. And for ethambutol, it is EMB-B genes. To talk about the elephant in the room, that is our GeneXpert, the cartridge-based nucleic acid amplification technique. It is nothing but an automated real-time PCR for you. The upper advantage for this is, first of all, it has been introduced into our National Tuberculosis Elimination Program. It has been provided to all the bigger medical centers, to all the government centers, so that the early diagnosis can be made. And the biggest part on this is it can rule out the multi-drug resistance also, the rifampicin resistance, which verifies the property for MDR. It can pick up that also. So it is a fully automated one-step system. It takes 1 hour and 20 minutes, less than 1 hour, 120 minutes to identify the diagnosis. And we don't require a biosafety cabinet, though in NABL we talk about that, yes, during the processing, during the buffer part, we require a biosafety cabinet. So that is always a gray area when we talk about it. So it is much more specific, it is much more sensitive. And the sensitivity and the specificity is very, very high. When we talk about the sensitivity for the diagnosis, it is almost 93% specific. This is one brief thing about. So when we talk about GeneXpert, within 2 hours, within less than 120 minutes, we can have the diagnosis via GeneXpert, whereas microscopy can take up, eventually, as I said, it might take up time, but the 2 samples has to be given at 2 fraction of time. So liquid culture, it can take up almost 14 to 15 days. Solid culture, more than, as we said, 2 to 8 weeks can be taken up for the LJ media to grow. So definitely, even for the rifampicin resistant, for the liquid culture, we have to wait for 30 to 45 days. For conventional LJ media culture, it requires more than 75 days, whereas GeneXpert, less than 1 day, I mean, less than 2 hours, we can have the positivity of pulmonary tuberculosis or the tuberculosis extrapulmonary TB also, along with the drug resistance also. So what is the main funda? So it is basically divided into 5 steps. The principle behind is, it is, as I said, it's a real-time PCR. Mainly the mutations of RPOB gene can also be picked up by these, and it uses 5 probes targeting the various sequences of RPOB gene. I think almost 23 RPOB gene sequences are targeted via this cartridge-based nucleic acid amplification. So the sputum liquefaction with the buffers and inactivate kar diya jata hai. 2 ml of sample is carried out. This is a ready-made cartridge. That is why the name is given, cartridge-based nucleic acid amplification. So this ready-made cartridge is available to it. In that, you just have to transfer 2 ml of the sample, whether it is a pulmonary sample or any exudative sample is there. This cartridge, then it is a single system also. It's a closed system, but it can have different parts. 1 part, 4 part. There are levels up to 64 parts also, which is available with CBNAT now. So this cartridge is inserted, and the filtering and washing of the sample picks up. So DNA is procured, and after that the reagents are mixed up, and with the semi-nested real-time amplification, the detection of MTB is somehow, it looks like this. So it is detected to be MTB, it is detected low, high, or medium based on that, or not detected. And if it is detected, how much the quantity is there, and rifampicin is detected or not, that can be picked up for the MDR TB. As I said, that 3 specific primers with 5 unique polar probes are available. And the limit of detection for this CBNAT is 131 colony forming units, or bacilli can be picked up per ml. And I've just mentioned it, it is 23 RPOB genes mutations, which can be detected by cartridge-based nucleic acid amplification. Moving on, next for the diagnosis of MDR TB, we have the line probe tests. One is the INO-LIPA, or the other one is genotype MDR TB. So line probe assays, the helpful part is, again, the steps for the PCR steps are the same. We go for reverse hybridization, and then Finally, we have the proper graph, the proper pictorial graph with us, that line, that one complete strip is along with us, from where we can identify the rifampicin resistance, isoniazid resistance that is leading to CAT, G and INHA gene if it's there. Directly from the sputum smear, we can go for this line probe assay and we can help in the diagnosis of MDR-TB, whether the patient is suffering from multi-drug resistant tuberculosis or not. So as I said that the procedures are the same: decontamination, DNA is extracted, and finally the PCR amplification takes place. That is a procedural activity for almost 5 hours. After that, for 2 hours, reverse hybridization is done, and finally the result and the interpretation looks somewhat like this. So you have your own card with you, and which can be matched up with the RPOB gene, whichever line is reproducing the same the cards which are available. So according to that, you have to give it, whether it is RPOB wild or the mutant, CAT mutant or the wild one, INH wild or the mutant one. So the important part for genotype MDR-TB here is it demonstrates excellent accuracy for rifampicin resistance, which is nothing but the proxy for MDR-TB only. As we say, कि अगर rifampicin resistant आ रहा है, तो obviously MDR में जा रहा है patient, and it has a good utility as for repeat for screening tools, and especially for patients with HIV MDR-TB. It is very helpful tool for the diagnosis of multi-drug resistant tuberculosis. As I said that DNA PCR based hai, so in a conventional line probe assay, whereas in genotype MTB-DR, we have a upper hand saying that easily extracting of the DNA, and most importantly, apart from rifampicin, we have this isoniazid, CAT-G and INHA genes can be picked up. The mutations and the wild strains can be very well picked up on genotype MTB-DR. Just the similar picture. Then the other modality when we talk about it is RT-LAMP. It is nothing but isothermal loop amplification technique. It started as a boon somewhere in late of 2007-2008. The upper hand to this is it is a very rapid test. Again, within 2 hours, including the DNA extraction, we can pick up just like CVNAT. It is definitely simple. Even in extrapulmonary TB patients also, this is very helpful. And as less as the quantification, whereas that detects 130 colony forming units, it is more sensitive for the 10 copies of TB DNA which can be detected. The only thing is it requires more of a trained technical staff and the more of the cumbersome activities there. Whereas that picks up the 3 primers, this has got 6 primers for 8 distinct regions. As I said that हमने कन्वेंशनल से स्टार्ट करा था सॉलिड, वी फॉर फिनोटिपिक वी हैव लिक्विड कल्चर, फिर हम एमडीआर टीबी पे आए लाइन प्रोब ऐसे में, एमडीआर में फर्दर वी हैव एमडीआर जीनोटाइप टीबी, देन वी केम ऑन टू जीनोटाइपिंग ऑफ एक्सडीआर और द एक्सपर्ट प्लस. सीबीनेट का ही एक और वर्जन हमारे पास है विच इज नथिंग बट जीन एक्सपर्ट अल्ट्रा भी उसे कहा जाता है, and it contains 2 additional molecular targets to detect the TB insertion sequences, which are IS6110 and IS1081. Definitely, just like this GeneXpert only, it is very much sensitive and specific, but that has got the detection limit of 131, whereas this GeneXpert Ultra can pick up 16 bacilli per ml also. This is one algorithm when we talk about pulmonary tuberculosis. This is interesting. I think earlier we just used to have this chest X-ray and the sputum smear. सबसे पहला जो हमारा algorithm आया था for pulmonary tuberculosis, we just had smears and just had this X-ray. Of course, the clinical picture from the first slide only, I definitely defined it. That clinician, pathologist, and a microbiologist opinion and the collaborative action is very important. So now with NTEP, we have this. You must be thinking about what is this HIV, which it is nothing but already the patients which are there. First of all, presumptive pulmonary TB की हम लोग बात कर रहे हैं, and PLHA is nothing but people living with HIV and AIDS. Just 1 second, I think. I think the connection went. I hope everybody can hear me. Okay. So when we talk about where were we? Yeah, person living with HIV. So if it is considered to be as already positive, we go for this for presumptive TB patients. We go for smear and chest X-ray. 2 smears are positive. Obviously, we can go for the microbiology confirmed tuberculosis. If we don't have, one smear is positive and chest X-ray is not supportive, think of going for a CB NAT. Chest X-ray, it is giving a suggestion, but smear is not positive. Think about going for a CB NAT, that is cartridge-based nucleic acid amplification technique. Very easily, वहाँ पे CB NAT पे अगर MTP detected आ गया, we don't have to start much. We look for the rifampicin sensitive, intermediate, or resistant. If it is first go only, we are having the diagnosis in our hands. We can think of putting up, yes, this is definitely a pulmonary TB positive patient. But if it's not, go for a repeat CB NAT for the second sample. And either of the modalities, smear, chest X-ray, CB NAT, if it's not giving us, think of going for alternate diagnosis, or you have the molecular modalities, clinically diagnosed, or repeat after 15 days, you can come back and think of having the repeat exercise with us. One word when we talk about the gene mapping or for the insertion sequences 6110, we have restriction fragment length polymerism, we have polygotypings, and we have the mirus. One by one, I'll just take up. So insertion sequence 6110 ki agar hum baat kare, it has got a high discriminative power, and it is very easy for the quick identification from the culture isolates only, and directly from the clinical specimens, this can be picked up. This is what RFLP sequences looks like. Then we have this spacer oligotypes or the oligotypings. This is interesting. The polymorphism of DR sequences jo aate hain hamare paas. So for that, testing by hybridizing their PCR amplified DR region to a membrane that consists of an array of almost 43 bound oligonucleotides representing the polymorphic spaces, which is identified by nothing but the typical strain of H37RV-DR sequence of Mycobacterium tuberculosis. Again, the upper hand is DNA is required and easily interpretation can be done. This is what it looks like in the picture. Then we have the Mycobacterium interspersed repetitive units, the mirus, what we call about. One second, I think there is a glitch. And when we talk about the limitations, what are the limitations? Of course, it is cost effective. The cost is very, very high, not easily available at all the levels, and not for all the drugs we can pick up. So CB NAT and line probe assays can be one of the helpful identifiers, and only available for specific samples. When we talk about the point of care testings, for making up the clinical decisions, it is highly, highly sensitive. Point of care testing instruments are any day much more easily accessible, but the only limitation what we go through is the cost part, not readily available at all the parts of the country. So the diagnosis of TB at the remote areas becomes our challenge. When we talk about serological parameters, we have the pass-plaque assay, which is nothing but your ELISpot, taking up the 2 ESAT and the CFP10 proteins. Generally, quantiferon gold nowadays not taken up. It is not at all recommended. पहले से TB gold कहा जाता था या quantiferon gold कहा जाता था, but it is never ever called as the gold standard for TB. This used to be one of the entities which was always in debate. Yes, it is good for latent TB, but eventually nowadays it is not much of importance. One word about the microarrays and the biochips. Again, rapid test, point of care testing, but cost matters. So you have all the tests available with you. You have the microscopic era, you have the culture era, you have the molecular era with you. So you have analytical, you have pre-analytical, you have the post-analytical changes. I think the quality assurance cycle here, it says that if your patient has given the sample, whether it was appropriate or not, whether it was given at the right time or not. So how the patient has collected the sample, that matters. So if it is coming from a remote area, whether the whether the sample was transported at a correct time or it is kept for almost 3 to 4 days where bacterial contamination would have added up. Then the proper labeling of the sample. Let's say X patient is suspected of TB, but the Y patient has been given the wrong barcode, eventually wrong diagnosis, wrong person, and patient may sue also nowadays thanks to NABL. Then the quality control testing. So whenever we are putting up, we cannot have this H37RV strain for usual purposes, but for the quality check of the slide of ZN staining, we need to have a quality check with a proper 3 positive sputum smear, and the negative control is taken as E. coli. How well we are keeping the record? There are multiple from the TB sources, from the districts TB sources. We have multiple registers to be maintained, and proper and the timely reporting of the TB should be there, whether it is by the older methods, whether it is by the culture which is taking enough of time, or whether it is by the molecular methods, as we say CBNAT and LIPA can be one of the modalities. Lastly, if we talk about how our system, how our Indian system works like, we have this pyramid of peripheral PHCs, then we have the normal, our medical college centers or the standalone labs or the hospitals. Then we have the referral laboratories, and last but not the least, it is a national reference laboratory which can give the further enhancement to it. So at PHC levels, we can just have a screening with the minimum resources what we have. So fraction of patient, if we seen at a given point of time, it is not more than 60%. Then we have the passive case finding, which is generally the current how we test for the microscopy and for the culture. You detect it and you treat it, so that is 25%. But eventually, patient is leading up to MDR or XDR. So again, culture and drug susceptibility has to go. That has to go to a referral lab. So how many amongst that comes up? That is just 10%. And 10% beyond that, if anybody is going for XDR, for network supervision, it is just 5%, which is reaching the national reference laboratory. Last but not the least, if I conclude, I have to conclude the microbiological diagnosis of TB will be rapid and accurate if and only the samples are collected with the proper quantification, proper quantity is there, proper timing के साथ अगर हमारे पास पहुंचती है, and definitely the correlation between the clinician, pathologist, and the microbiologist when if it's a case of extrapulmonary TB has to be there. Future of TB, definitely it is with the newer molecular technique, but the interpretation of the result is in the hands of a good clinician or in a good microbiologist or a pathologist, and definitely with the help of a good clinician you can identify it. Sensitivity of the molecular tests vary and is affected by the amount of bacteria present in the samples and also by the clinical correlation what we just spoke about. So new molecular method cannot be substitute to the conventional one. So as in the starting of my conversation when I started, as I said, the gold standard for us remains the culture, and the other methods have to be considered and interpreted as complementary diagnostic methods. So coming from a microbiology, of course, culture will have the gold standard. You will have the colony forming units. You have the colony counts with you. You can have a morphology of the bacteria, which is ideally reciprocating to the Mycobacterium tuberculosis. So, and most importantly, the communication between the clinician, microbiologist, and even for that matter, a pathologist is imperative. So when we talk about NTEP, it is National Tuberculosis Elimination Program. TB ko Bharat Mukt karna hai. I have been hearing Amitabh Bachchan saying, 2 हफ्ते से ज़्यादा खांसी. This is what is algorithm of pulmonary TB all about. 2 हफ्ते से ज़्यादा खांसी TB हो सकती है. So you have to go, you have to correlate. The clinician has to send the sample at the right point of time, and then you have a cocktail of diagnostic modalities there with you. What we can use, how we can use, and how well we can look forward. So this was